The next type of mechanical energy that I'm going to talk about is kinetic energy. So kinetic energy is the energy that an object has because of its motion. So the net work done on an object to move it is going to be equal to the change in kinetic energy. So remember that work and energy are equal to each other because of the work-energy theorem. So we have two equations just like we did when we looked at gravitational potential energy, where work is equal to the change in kinetic energy. And in this case, when an object is moving, the part of its kinetic energy that's changing is actually its velocity. So if we look at its instantaneous kinetic energy, we have this equation here, 1/2 mv squared, or 1/2 the mass times the velocity at that instant squared. So if we wanted to calculate the change in kinetic energy, we would calculate the kinetic energy at one point based on its velocity, and then if it were to slow up or slow down or speed up, then we would calculate the kinetic energy at some different point, and that would be the change in kinetic energy or the work. So let me just go ahead and do an example of a calculation for kinetic energy. Alright, so the first one is just going to be instantaneous kinetic energy. It says, what is the kinetic energy of a truck weighing 1,500 kilograms moving at 8 meters per second? So kinetic energy is equal to 1/2 the mass times the velocity squared. So in this case, we're going to take 1/2 times 1,500 kilograms times the velocity squared, so it would be 8 meters per second squared. Oh, that looks like 8 meters per second squared, like its acceleration. Let's put the square out here. Alright, so I'm going to punch it in, and I'm going to do 8 squared times 1,500 times 0.5. And I get 4.8 times 10 to the 4th joules. Okay, so that would be the kinetic energy it has at that instant. Now it says, well, what if that truck accelerates from 8 meters per second to 12 meters per second? What is the work done? So remember, I worded it like this because it says, what is the work? And we know that work is equal to the change in energy, and in this case, the change in kinetic energy. So we know that initially its kinetic energy is 4.8 times 10 to the 4th joules at 8 meters per second. So let's figure out what it is at this speed, and then the difference between those two values would be the change in kinetic energy or the amount of work done. So, and we're going to figure out the kinetic energy, and we'll say like at 12. So that's going to be 1/2 times 1,500 times 12 squared. Okay, so again, let's pull up the calculator. 0.5 times 1,500 times 12 squared, and that gives us 10.8 times 10 to the 4th. I know that's not good scientific notation, but it'll make it easy for us to compare those two values. So 10.8 times 10 to the 4th joules. Now if we have the same exponent here, we can just subtract those two from each other, and because they're pretty close to one another, it's some easy math, right? So it's going to be 6 times 10 to the 4th joules. So I'm just taking 10.8 times 10 to the 4th minus 4.8 times 10 to the 4th to get the change in kinetic energy, or the work. And so this would be 6 times 10 to the 4th joules. So this would be my answer for change in kinetic energy.